Arguably the oldest species of humans, Homo habilis was preparing the way for human evolution in Africa 2.4 million years ago. On the plains, scrublands, and forests of East Africa, some 2.4 million years ago, life was not easy. Predators roamed the wilds, and food had to be fought over. Constantly having to look over their shoulders and above the tips of tall grasses, a short but upright walking species of hominin strove for survival, just like all the other animals with whom they shared the land. They were small. They didn't have any special physical features that could help them win fights against hyenas, wild dogs, lions, and other dangerous creatures. They did, however, have something special that helped them survive and eventually evolve. They had large brains. Brains that would evolve into the brains we have today. This was Homo habilis, our plucky ancestor. The first remains of Homo habilis were discovered in 1959 by Lewis and Mary Leakey, although at the time, they did not realize that what they had found belonged to a separate species. The Leakeys had been excavating remains in the Olduvai Gorge in East Africa for decades, and had uncovered the remains of Paranthropus boisei, a relative but not a direct ancestor of humans. Their son, Jonathan Leakey, discovered the remains of a recognizably different hominin. In 1964, it was classified as H. habilis, and it represented the oldest species in the Homo genus. After the discovery, debate raged about where and how the species fit into the evolutionary tree. It had been presumed up to this point that humans had evolved in Asia, but this discovery changed the entire picture. The eventual consensus was that the Homo genus, along with the Paranthropus genus, had evolved out of Australopithecus africanus. The most common theory of what happened next is that the Homo genus was, 2 million years ago, split into Homo habilis and Homo rudolfensis, with Homo habilis evolving into Homo erectus, ergaster, then Homo heidelbergensis, rhodesiensis, and finally into Homo neanderthalensis and Homo sapiens. Despite the acceptance of this theory, many academics in the field are willing to admit that the evidence for it is not solid enough to warrant it being taught as fact. It is subject to amendment when new evidence is presented. The debate around H. habilis is that, while it is likely H. erectus evolved from them, it is also possible H. erectus evolved from H. rudolfensis, or both, or neither. Until recently, H. rudolfensis was classified under the Paranthropus genus, so the theories are malleable. Some believe H. rudolfensis and H. habilis are not even separate species, and the remains that have been found of H. rudolfensis represent female H. habilis. Evidence shows that Homo habilis used Oldowan-style lithic technology. While innovative and revolutionary, it was still leagues behind what Homo erectus would be able to do. H. habilis seems to have created tools by opportunistic striking of rock cores until a reasonably well-shaped lithic flake appeared that would be suitable for what the individual needed. This is a far cry from the Herculean technology, where lithic cores were prepared with specific tools in mind and then worked and shaped into the desired form. This is not to say H. habilis knew nothing of what they were doing. They recognized certain rocks would produce certain types of flakes when struck in the right place and with the right amount of force. Tool usage in H. habilis shows that they were definitely on the path to becoming human, but they lacked the necessary creativity to create the complex items that their descendants would make. The tools used tended to be sharp, cutting instruments, and were used to butcher meat, as it is assumed H. habilis was a prolific meat eater and lived a scavenger lifestyle. Cutting flakes were also used to skin animals and to cut plants. H. habilis was close to the Australopithecines on the evolutionary timeline, and while some aspects of them hinted at a future that would evolve into modern humans, H. habilis was for the most part far more ape-like. Estimates on how tall this species was vary greatly, as no consensus has been reached on how long their legs were in relation to their bodies. Therefore, estimates on one particular specimen, O62 female, range from 3 feet 3 inches to 4 feet 10 inches. They were not, however, the shortest species in the Homo genus. That honor goes to Homo floresiensis, an extant species of Homo erectus, likely, that was discovered on the island of Flores in Indonesia. It is assumed that there was notable sexual dimorphism, with females being significantly smaller than males. However, the extent of this dimorphism is unknown and can only be guessed at. It is also an educated assumption that H. habilis was covered in fur, similar to our modern ape cousins like gorillas and chimpanzees. Popular theories suggest that H. habilis lived in colder climes and did not have the active lifestyle that later hominins would have, and thus they needed a thick coat of fur to stay warm. They also had long, well-developed arms, suitable for arboreal activities, which suggests they inhabited a time in evolution when our ancestors had not fully adapted to living life on the ground, and were still very reliant on trees for safety. Their heads and faces also showed a mix of ape-like and human features that reflect their position on the evolutionary tree. Their lower face, that is, the area around the mouth and jaw, jutted outwards, prognathic, is similar in a way, but much less pronounced than our ape cousins, such as chimpanzees. From the nose up, their faces were much flatter. They had heavy brow ridging and sloping foreheads, typical of our ancestors, but much less sloped than their immediate Australopithecine ancestors. Their cranial capacity varied widely and was between 500 to 900 cubic centimeters. Thus, their brains were a similar size to that of their contemporaries, H. rudolfensis, and their evolutionary descendants, H. ergaster erectus. For reference, modern humans have a cranial capacity generally between 1400 and 1500 cc. Homo habilis was so named because of the evidence of tool use far above the levels previously seen in human evolution. Habilis is Latin for handy or useful. Simple stone tools were used in abundance, with certain tools being used for specific purposes. Tools were used as cutters, tenderizers, and crushers, while hand axes were used to shape sticks into rudimentary spears or shovels. Creating tools was thus an important part of H. habilis' culture and lifestyle. It is unknown how they interacted on a sexual level. It is widely assumed that Homo erectus was the first hominin to practice monogamy, and thus, it is thought that H. habilis was polygynous and exhibited traits in this regard similar to current ape relatives, such as male-to-male combat, in order to secure a mate. There is evidence for this theory, however. There is also evidence against it, so very little can be said for sure about the mating habits of H. habilis and how the sexes interacted. H. habilis, being at the smaller end of the hominin size spectrum, was also an easy target for predators. As such, like all our ancestors and cousins on the evolutionary tree, H. habilis was communal. It has been suggested that brain size plays an integral part in the size of ape troops. This is referred to as the Dunbar's number, or monkey sphere. It determines the cognitive limit of maintaining social relationships. Robin Dunbar, who created the theory, states that H. habilis had a Dunbar's number of 82, and their troops probably numbered around 70 to 85 individuals. By comparison, modern H. sapiens has a Dunbar's number of 150. H. habilis was also not the only hominin in the African forests and savanna. They shared their world with the similar H. rudolfensis, Paranthropus boisei, and, later on, H. erectus ergaster. How these species interacted with each other is unknown and subject to much speculation. H. habilis was likely a confrontational scavenger. They were well equipped when in a group and, armed with rocks and sticks, were able to challenge predators and other scavengers, driving them away from a kill and claiming it as their own. They were ill-suited to actual hunting. It was only with the evolution of H. erectus ergaster that humans developed the evolutionary game-changer of being able to run long distances. They were, however, suited to traveling long distances, and it is thought that H. habilis could have been the first hominin to leave Africa. Their diet also seems to have included fruits and tubers, although meat became an important part of their diet. This attention to a carnivorous lifestyle is considered the catalyst for the enlargement of the human brain through the evolutionary eras and became more prominent in H. erectus ergaster. Homo habilis existed for around 700 to 800,000 years in total. During that time, their world would have gone through many climatic changes, and they would have had to constantly adapt, giving rise to the evolution of adaptability that would come to characterize the human species. They also showed the first signs of tool usage and were instrumental in evolving the foundation of humanity as it is known today. It is possible they had rudimentary speech, and although extremely complex when compared with other animals, it was nowhere near the complexity of speech in modern humans. This theory is supported by the enlarged Broca's area in the H. habilis brain, which in humans plays a significant part in the ability to understand, construct, and use language.